Welcome to section 9.1.1. We're going to be talking about sketching the graphs of polynomial functions. So once again, a polynomial function should be written in standard form. For it to be in standard form, we're going from the largest exponent to the smallest exponent, largest degree to smallest degree. So there it is written in math speak. Don't worry about that too much. Just know largest exponent to smallest exponent. Now we can talk about what's called the end behavior. The end behavior of a function is determined by the degree and the sign of the leading coefficient. So when the degree is odd, so that would be something like cubed or to the fifth or even to the first, and the leading coefficient's positive, our end behavior is going to look something like this. We'll talk about how many turns it'll take as we keep going through. So we would say that it falls left and it rises, to the right. That's the end behavior. What I like to do is I like to think about it as a line with a positive slope. All we care about is what's happening on the left and what's happening on the right. When the degree is odd and the leading coefficient is negative, it's going to go like this. It's going to be kind of flipped. It's going to now rise to the right, and it's going to fall to the left. Think about a line with a negative slope. Now, when the degree is even and the leading coefficient is positive, it's going to look something like this, where it's going to rise left and rise right. So this is when you have something like squared, or to the fourth, or to the sixth. Think about a parabola opening up. You see how it rises left and rises to the right? So now, when the degree is negative when the degree is even and the leading coefficient's negative, it's going to fall left and fall right. Think about a parabola opening down. It's that same type of situation. Now, when we talk about the zeros of a polynomial, the zeros are the solutions, also known as the roots. Roots, zeros, solutions, they're all the same thing. They're all the value of x when y equals 0. Repeated zeros, sometimes they're repeated. That's what we call multiplicity. So when the multiplicity is odd, it crosses the x-axis at that point. When the multiplicity is even, it bounces. And we'll talk about that as we go through. So for odd, they would go through. Those would be the zeros there. And for even, it would bounce. So where it just touches the x-axis. Those would be even multiplicity. Like I said, we'll be talking about that as we go through. Let's go to some practice problems. Now we're going to find the degree, and we'll make a quick sketch. Now they're not going to be perfect. So what we do is we look at it here and say, all right, this binomial is squared, so it's x plus 5 squared. So that would give us an x times an x squared, which would give us an x to the third. So our degree would be 3, and that is odd. Our leading coefficient, the number in front, is a 1, which is a positive. So we know our graph, because it's odd and the leading coefficient is positive, is going to look something like this. Now we can also make some assumptions based on our zeros, the x-intercepts. Set the binomials equal to 0. So 2, 0, negative 5, 0. Now this one is repeated twice. So we can make a really rough sketch. Negative 5, 0, positive 2, 0. Now, in order for it to fall to the left and rise to the right, what's going to happen at negative 5? It's going to go up, hit there, bounce back down, and then go back up and through. And that's a quick sketch of what it would look like. You can graph that on your calculator and you'll see the same thing. For number 2, the degree. Count up the x's. None of them are squared or anything. So 1, 2, 3 x's. So it's x to the third. So the degree is 3, which is odd. And the leading coefficient is a 2, which is positive. So we know the sketch is going to look something like that. Now our x-intercepts are zeros. For the first one, x is 2, so 2, 0. For the second one, it's a negative 2, 0. And for the third one, it's a 3, 0. They're all odd multiplicity. So there's our negative 2, our 2, and our 3. So for it to look like this, it's going to go up, through, back down and through, and then back up and through. And there's a quick sketch of our graph. It's going to have that basic shape to it. For number 3, the degree is 4, which is even. The leading coefficient is 4, which is a positive. So based on that, our graph is going to have this basic shape to it. It's going to rise left and rise right. Now we have to do a little bit of work to find our zeros. We're going to actually factor this. So 0 equals, now a common factor of those 3 terms is x squared. So it would be 4x squared minus 21x plus 20. And then we can continue factoring it, x squared. And now when we factor this quadratic, we get 4x and x, and to get that, multiply to 20 and add to negative 21, minus 5 plus 4. So you set each factor equal to 0, x squared equals 0, 4x minus 5 equals 0, and x plus 4 equals 0. So our solutions, x equals 0, there's 1. X equals 5/4, and x equals negative 4. So because this first one is squared, that one's repeated twice. The other two are only once. So at 0, at negative 4, and at 5/4. Oh, excuse me, that's an x minus 4. Excuse me. So it's going to be a positive 4. So let's fix that up. So 0, 5/4, and 4. It's not exact. I'm just kind of making a sketch. So what's going to happen? Because 0 is repeated twice, it's going to come down, and it's going to bounce, and then go through and back up through. And you can see it's rising left and rising right. If you graph these on your calculator, you'll see something very similar. For number 4, the degree. So the first one, so we have x squared, then we have another x, and another x. So if we count them up, that's 2, 3, 4, 5. Our degree would be 5. Our leading coefficient is a 1, which is positive. So it's odd and positive, so the sketch is going to look like this. Might be a few more turns in there, but we'll figure that out as we go through. So our zeros, our x-intercepts, negative 3, 0 for the first one, negative 1, 0 for the second, positive 1, 0, and positive 5, 0. Because that's squared, the first one is repeated twice. So it's going to bounce. So I've got a negative 3, a negative 1, a positive 1, and a positive 5. So what's going to happen in order for it to have this shape? It's going to start going from the bottom. It's going to go up, and it's going to bounce at the negative 3 back down, turn around, go back up, through, turn down, through, and then back up, through. And it's going to have that basic shape to the graph. Number 5, the degree. When we count them up, that's 1, and then for the cube, that's 3, for a total of 4, which is even. Our leading coefficient is negative 0.1, which is a negative. Because it's even and negative, it's going to have this basic shape to it. Now our x-intercepts, for the first one, it's a 0. So it's at 0, 0. And for the next one, it's going to be at negative 4, 0. And that's 3 times. Because that's an odd multiplicity, it's going to go through. So here's 0, 0. Here's negative 4, 0. So what's going to happen? It's kind of going to go up and through, turn and back down. It's a little bit weird looking, but we only have 2 intercepts, and they're both of odd multiplicity. So that's kind of basically the shape it's going to look like. For number 6, the degree is 4, which is even. And our leading coefficient is a 1, which is positive, so it's going to have this shape to it. Now we need to factor this. 0 equals, and our common factor is x squared. So it's going to be x squared minus 9. We can keep factoring x squared, and x squared minus 9 is x plus 3, x minus 3. So our zeros, our x-intercepts, 0, 0 for the x squared, negative 3, 0, and positive 3, 0. And that first one is repeated twice. So there's our negative 3, our positive 3, and our 0. Don't forget, it's going to bounce at 0, 0. So to match this sketch, it's going to start, it's going to go down through, turn and go back up, and then it's going to bounce at 0, 0, and then turn and back up again. And there is our graph. Final 2. For number 7, the degree. Count up the x's, 1, 2, 3, 4. Leading coefficient, 0.2, which is a positive. So the shape, it's going to look like this. So now, our zeros, the x-intercepts. So we have for the first one, 0, 0, a negative 1, 0, a 3, 0, and a negative 4, 0. So when we make our sketch, they're all multiplicity of 1. So we have our negative 1 here, our negative 4, our 0, and our positive 3. So it's going to go through all of them. So it's going to start and go down through that one, bounce back up, go through, bounce back down, go through, and then bounce back up. And that's a brief and quick sketch of that function. And then the last one, number 8, the degree is 3, and the leading coefficient is 2, which is a positive. It's going to have this shape to it. So looking at it, we need to factor it. So 0 equals 2x cubed plus 3x squared minus 50x minus 75. When we have 4 terms, we can factor by grouping. The greatest common factor of the first 2 terms is x squared, and when we factor that out, we get x plus 3. 2x plus 3. The last 2 terms, the greatest common factor is a negative 25. And when we take that out, we get 2x plus 3. The common factor of both is 2x plus 3. And then we're left with x squared minus 25. So it's 2x plus 3, and it's x plus 5, x minus 5. So we set each factor equal to 0. 2x plus 3 equals 0, so x equals negative 3 halves, x equals negative 5, and x equals positive 5. So our x-intercepts, negative 3 halves, 0, negative 5, 0, and positive 5, 0. None of them are being repeated, so they're all going to go through. So here's our negative 3 halves, our negative 5, and our positive 5. This is just a rough sketch. So in order for it to meet this shape, it's going to go up, turn through and go down, turn back up and go through, and there's a sketch of our polynomial. Your calculator graphs should look similar. They might be a little bit different, but the basic shape and intercepts will all match up. All right, we'll be practicing these as we go through this chapter, and I will see you in the next section. Thank you.